Let us start with another problem. The problem goes like this. Find the number of 4-digit numbers that can be formed using the digits 0, 1, 2, 3, and 4 without the repetition of digits. So I would like you to solve this problem on your own. I'll just give you one hint that a number like 0, 1, 2, 3 or 0, 1, 2, 4 doesn't count as a valid 4-digit number. So these are 3-digit numbers with 0 in the first place. So you have to be mindful of that when you solve this problem. So the choices you have are given 120, 96, 24, and 150. The correct answer is 96. I hope some of you got it, but even if you didn't get it, it's fine because there is some degree of difficulty in this problem. So let us try to understand this problem now. So like before in the problems related to fundamental principle of counting, here you have 4 digits. So I will draw 4 boxes corresponding to those 4 digits. Okay. So I have the first, I'll call it the first digit, the second digit, third, and fourth. So here we have the first place. Let us start with the first digit. What are the possible numbers? So we have these numbers, right? 0, 1, 2, 3, and 4. So in the first place, what are the digits which I can use? What do you think? It's 1, 2, 3, and 4, right? Because 0 cannot occur in the first place. Otherwise, it won't be a 4-digit number. It will become a 3-digit number. So only 4 of these 5 digits can be used for the first place, right? So I call the number of digits that can be used for the first place as n1. So n1 is equal to 4, right? Now you have the second place. For the second place, how many digits are there? So you use one of the digits for the first place and you have 3 left, right? So you have n1 minus 1 left for the second place, but you also have 0, right? So 0 makes it 1. So again you have n2, which I call the number of digits which can be used to fill the second place. That is equal to n1 or 4, because you have 1 and 1, this cancels and you are left with n1. Okay, so this is because 0 is used in the second place, can be used in the second place. From the third place on, it is simple because now you just use n2 minus 1. So because whatever is used in the second place, you just use 1 less than that. And similarly, you have the fourth place. For the fourth place, I call this n2 minus 1 as n3, and this one will be n3 minus 1. Okay, so this one is equal to 3, and I'll call n4 equal to 2, right? So number of 4-digit numbers is equal to n1 into n2 into n3 into n4. I'm trying to explain to you, that's why I went through this procedure. Once you are comfortable with it, you don't need to write explicitly n1, n2, n3. You will just write like 4 digits are used for this, 4 for this, 3 and 2. So that should be fine. but because I'm trying to explain to you, I'm just elaborating on this explanation. So you have n1 equal to 4, and then n2 equal to 4 again, and n3 is 3, and n4 is 2. So if you calculate it, this is equal to 96, which is the answer, which I had marked before. So I would like to make one more point with the previous problem, that where we had 4 places, right, for a 4-digit number. So I had first, second, third and fourth place, and I had these 5 digits 0, 1, 2, 3 and 4. And the problem basically was that 0 cannot be used for the first place, because then it will not be a 4-digit number. So a number like 0, 1, 2, 3 was not a 4-digit number. That's why 0 does not belong to the first place. And we started filling the first place, then the second, third and fourth. What would have happened if we started instead from the fourth place? So if I started from the fourth place, how many choices were there for filling the fourth place? All the 5 digits could have been used, right? So if all the 5 digits could be used for the fourth place, I'll just keep the notation like before, then n4 will be equal to 5, right? Because everything can be used. And what about the third place? Third place, you just use one less digit than the fourth place because one has been used. So I just have n4 minus 1, that is equal to n3, and that is equal to 4. Good enough here. And then what about second place? Second place, again I do the same thing. You have n3 minus 1 equal to n2, and that will be equal to 3. Now we come to the first place. What do you think about this? First place, can we just say it is n2 minus 1 because we just use one less digit compared to the second place? Can we do that? Actually, you cannot. Why not? This again, the problem is basically because 0 cannot go in the first place. So depending on what you choose for the fourth, third and second place, your choices will change for the first place. For example, for the fourth place I choose 2, and for the third place I choose 1, and for the second place I choose 4. So what is left to choose for the first place? I have 0 and 3, right? Similarly, if I choose 0 for the fourth place, 2 for the third place, and 3 for the second place, what am I left with for the first place? 1 and 4, right? So here the problem is basically clear, that for the first place I have choices 1 and 4 or 0 or 3 depending on what I have picked for the fourth, third and second place. So if I have the choices 0 and 3, only one is allowed, and in this case 2 are allowed, because here 0 cannot be used. Here 1 and 4 both can be used. So this problem actually becomes harder now, because it's not clear how many options you will have to fill the first place. That is why it is better always that wherever you have the constraint, like you have the constraint here that 0 cannot be here in the first place, you start from the first place and proceed to fill the rest of the boxes. So if instead of starting from any other box like the fourth place, because this constraint will always be a problem, so better to focus on this particular limitation or constraint before. So in the next problem also, which we'll cover, it will be clear why you have to focus on the box with limitation or constraint.